Using precision and measurement. So your book defines precision as the level of detail that an instrument can measure. Precision has very little to do with how correct something is. It's just how detailed it is. So my watch measures down to the second. That doesn't mean that my watch is right. I could set my watch to be like 3 o'clock in the afternoon, and it's currently 10:26. And my watch would still be precise down to the second, even though it's not correct. So another way to put it, we got some people in here who have used firearms, which is a scary thought. All right, you could hit the same exact spot every single time you shoot and still be the worst hunter ever. But you would be precise because you'd hit the... I tried shooting, I don't know if you call it shooting if there's no like gunpowder involved. I tried firing a longbow for the first time, or a recurve bow for the first time this summer. Never fired a bow before. And fire, again, it's not fire. There's no fire involved. Although by the time I was done, I kind of wanted to light that recurve bow on fire because I'd never drawn a bow before. So I shot a recurve bow, and I hit like the exact same spot every time. Now that spot was not on the target, but all of the arrows ended up in the exact same spot. So, which made it much easier to stitch up my friend's leg. All the wounds were right in the same. I'm just kidding. So there, I was very precise, which is good. That's important. But I wasn't hitting the target. So precision doesn't doesn't cover whether or not you're correct. It just covers like how detailed you are. So your rulers are accurate down to the millimeter. They're precise to the millimeter, but that doesn't mean that you're correct. So if we look at example 1, it gives us some different measurements. It asks us to choose which is more precise. Doesn't mean which is accurate, but which is more precise. And really, whoever goes to the smallest amount of measurement wins. So, for example, A gives us 7 centimeters and 7.3 centimeters. Now, it's not asking you which is correct, because they're not even asking you to measure anything. They're asking you which is more precise. Think about it, like when you're a kid, like, how old are you? I'm almost 13, okay? Like, yeah, some of you have probably said that. I'm almost 13. I didn't want to know how old you are almost. I want to know how old you are, okay? Now, if we wanted to be really precise, we'd say I'm this many years, and this many months, and this many days, and this many hours, and this many minutes. That would be super precise, but usually we just like round up. So in this case, somebody probably rounded to 7 centimeters, but which is more precise? Which is more detailed? Ryan? The 7.3 centimeters is more precise. Doesn't mean it's correct, it just means that it's more precise. How about 5 yards, 16 feet? 2 separate measurements and 2 separate quantities. 16 feet is a little bit further than 5 yards. Which is more precise? Which is looking at a smaller unit of measurement? Seth?
The 16 feet.
The 16 feet is more precise. It's looking at a smaller unit of measurement. It's like if I were to measure the length of this building with yardsticks and with foot-long rulers, okay? With yardsticks, I could tell you how many yardsticks it is approximately. With rulers, I could get a little bit closer because they're smaller measurements, so I can get closer to the exact value. All right, how about 1 pint and 16 ounces? No, those are actually equivalent. A pint is 16 ounces. But which of those measurements is more precise? Emily? 16 ounces, because it's using a smaller unit of measurement. So it is more precise. Now, when we're combining quantities, we're going to be combining quantities with different levels of precision. And so we have to determine just how precise our sum or difference or product is going to be if we start with different levels of precision. And one of the ways we do that is by using what are called significant digits. Significant digits are the digits in a measurement that carry meaning, contributing to the precision of the measurement. Sometimes you'll hear it referred to as significant figures. It's the same thing. Significant digits are the digits in a measurement that carry meaning, contributing to the precision of the measurement. So, when you're looking at a number, you have to determine how many significant digits there are. And so here's what we count as significant digits. All non-zero digits are significant. If it's not a zero, it's significant. So your book uses the number 281.39. That has 5 non-zero digits. Those are all significant. So you have 5 significant digits. Now for a nice long one. Zeros that are to the right of both the last non-zero digit and the decimal point. In other words, if I had the number 0.0070, the 7 is significant because it's a non-zero digit. This 0 is significant because it's to the right of the non-zero digit and also to the right of the decimal. Has to be both. So these zeros don't count because they're not to the right of the last non-zero digit. So the only 2 digits that count are the 7 and the 0 that's to the right of it. So that has 2 significant digits. And the last ones we count are the zeros between other significant digits. So if I had 500.7, 5 and 7 are significant because they're non-zero digits. The zeros between them are significant as well. So this would have 4 significant digits. So let's look at some examples of that. 290.01 grams. First thing we count are the non-zero digits. How many are there? How many non-zero digits are there? Yeah, 3. There's 3 numbers in there that are not 0. Then we look for zeros that are to the right of the last non-zero digit and the decimal point. Are there any numbers to the right of the decimal point and the last non-zero digit? No, they would be over here if there were. There's none there. Okay. Then we count the zeros between significant digits. How many are there? 2. Right here and right here. So how many total significant digits do we have? 5 significant digits. Not only are you going to use this in math class, you'll use it later in science. So make sure you really understand this. The next one, 0.8500 kilometers. First, we're looking for non-zero digits. How many do we have? We have 2 non-zero digits, 8 and the 5. Then we look for zeros to the right of both the decimal and the last non-zero digit. How many are there, Seth?
2.
2. Right here and right here. Then do we have any zeros between significant digits? No. So how many total significant digits do we have? 4. All right, how about 4,000 miles? How many non-zero digits do we have? 1, just the 4. Do we have any zeros that are to the right of the last non-zero digit and the decimal place? No. We don't even have a decimal point there, so we don't have any to the right of it. How about any zeros between significant digits? Do we have any of those? No. So how many significant digits do we have? 1. Now, I could change this just a little bit and get you 5 significant digits. If I wrote 4,000.0, okay, the 4 is significant because it's non-zero. The 0 after the decimal place is significant because it's to the right of the last non-zero digit and to the right of the decimal place. Right? And then all of the zeros in between are significant because they're between 2 significant digits. And so now it's 5 significant digits. So when we put that 0.0 there, what that's indicating is that we've measured it down to the 10th of a mile and determine that there's 4,000 and 0.1 of a mile. If I just wrote 4,000, I could be communicating that there's exactly 4,000 or that there's approximately 4,000. And so since there's a lack of clarity there, we only count the 4 as significant. Now, when we're combining numbers in significant digits, we have to pay attention to how many we have. So, if we're adding or subtracting, we round our answer to the last, or to the same place, I should say, as the last significant digit of the least precise measurement. So for instance, if I had 3.24 plus 7.3, which of those is less precise? Emily? 7.3. That only goes to the tenths. The 3.24 goes to the hundredths. So the 3.24 is more precise. 7.3 is less precise. So after we add these, we're going to round to that decimal place. Since the 7.3 is less precise, and that ends in the tenths, then I need to round to the tenths place. What is 10.54 rounded to the 10th place? Seth?
10.5.
10.5. That's where we would round it. Now notice it says least precise. It doesn't say least amount of significant digits. It says least precise. So for instance, if I had 4,000 and I added 0.5, both of those have one significant digit. But which one is less precise? Seth?
The 4,000.
The 4,000, because it is accurate, or it is precise only to the thousandths place, whereas the 0.5 is accurate to the tenths place. So when I add them, I have to then round to the thousandths, to where the 4, to the thousands, where the 4 is, and so that would still round to 4,000. I mean, if you think about it, somebody asks you how much you got in your bank account, you're like, I got about $4,000. Like, oh, here's 50 cents. How much do you have now? About $4,000. That half a dollar doesn't make much of a dent in the 4,000, and so we just kind of round it off. So for addition and subtraction, we round to the same place as the last significant digit of the least precise measurement. For multiplication and addition, or division, sorry, multiplication and division. We round, this is where it's a little different, we round to the same, not same place, but same number of significant digits as the least precise measurement. So if I did 40 times 31, which of those is less precise? Yep,
40.
the 40. The 40 is precise to the tens place. The 31 is precise to the ones place. The 40 has one significant digit, and the 31 has 2. So since the less precise one has one significant digit, I'm going to round so that I only have one significant digit in my product. Yes?
You would get 30.
I'm sorry?
If you were going to round.
I'm not going to round the 31 though, I'm going to round my product. I'm going to multiply first. So I multiply the 40 times the 31, and I get 1,240. Then I want to round that so that there's only one significant digit. Well, if there's going to be only one significant digit, it's going to be that first digit there. So if I round to the thousands place, what do I get? 1,000. Let's do 2 more quick examples. 45.1 plus 19.45. If we add those, we get 64.55. What place should I round to? Which one's less precise? Where does it end? That's where we round. Which one is less precise? And where does that end? Seth?
45.1 is less precise, so you would round to the tenths place.
All right. The 45.1 is less precise, and it ends at the tenths place. So I round to the tenths place, and I get 64.6. If I'm multiplying 6.4 times 2.15, I get 13.76. 6.4 is less precise and has 2 significant digits, so I should end with 2 significant digits, which means I would round to 14. All right, have a good